Hi and welcome to the Davos in the Desert podcast series. These podcasts feature thought leaders in business and public policy. Our intent is to be informative and thought-provoking. This session is part of Davos in the Desert's Data Center Cooling Technologies Conference. Our guest is Herb Zine. Mr. Zine served as CEO of LiquidCool Solutions from 2013 to 2017, co-chairman from 2018 to 2020, and continues to support LCS as vice chair of its board of directors. Without further ado, here is David Waintick, Davos in the Desert's CEO and podcast host.
So we're familiar with some of the problems that arise in data centers. Data centers get very hot, and we need some technologies to cool down the data centers. So Herb, maybe tell me a little bit about how LiquidCool Solutions reduces the heat in data centers.
First of all, frankly, as a thermal engineer, the way data centers have been cooled for decades is ridiculous. Air is the worst possible medium for moving heat around. My friend and I co-founded what became the largest district heating and cooling system in the U.S. We own the downtown's energy systems in 11 cities, served by 21 central utility plants. We sold a lot of chilled water to data centers in various cities. And I'd walk into these places and I'd say, as a thermal engineer, they've got this hot thing in the middle of the room and they're blowing cold air at it. I'd say, really? So when we sold that business, I became an angel investor. And these folks from really IBM presented to our group. They spun out to do gaming with liquid cooling by immersing the boards in a dielectric liquid, which is a liquid that conducts heat but not electricity. And of course, from my earlier days as an employee, as an engineer at Dominion Resources, the electric utility, we use that kind of system for cooling high voltage transformers in substations. And I thought to myself, of course, this is the way you would cool data centers. I mean, you eliminate air altogether, which is very inefficient. And so what we do at LiquidCool Solutions, we now have 63 patents globally on cooling electronics by immersion, but it's a rack-based or chassis-based immersion that fits in standard data center racks. And we use forced convection to cool the hottest components. So right now the chips are just, one good thing that's moving this along is that air can't do it anymore. The chips are just too hot. So there's no amount of air that can cool some of the current processors out there. And so forced convection to cool the hottest processor is meeting with the rest of the fluid in a chassis so that 100% of the heat is removed in the liquid, reduces the energy in a data center up to 40%. And we reduce the maintenance cost of equipment over 90% because we don't have any chillers. If it's cooler than 115 degrees Fahrenheit outside, we simply can blow the heat away. So through the dielectric liquid, using what's called a dry cooler, similar to the way your car radiator system works. So it's a revolutionary step, but there are other people doing liquid cooling, and it's because of there's various flavors. We think that the chassis-based immersion with forced convection is really the end game. And so that's what we do.
So help us visualize exactly where your immersion cooling technology is placed. Is it placed between racks? Is it placed on servers, inside of servers?
So we sell servers. And the immersion is in the servers, and the fluid is pumped out to a heat exchanger at the rack. The facility coolant, which is now becoming universally available because of the hot chips, because of AI and other things, the facility coolant goes to the rack, picks up the heat, and then goes to a dry cooler outside someplace. Alternatively, if there's a need for hot water at 140 degrees, that all of that energy can be actually recaptured in the form of 140-degree water. So if you have a concurrent requirement, like if you're in a hospital or if you're in a university situation, where there's a concurrent need for both computing and hot water, you can get effectively almost a zero carbon edge computing system. It's pretty amazing, actually. Not only do we do that, we don't consume any water, which in many parts of the world is becoming an increasingly important consideration. No water is consumed. We reduce the data center space by 70%. We reduce the energy by up to 40%. We eliminate chillers, cooling towers, water treatment systems, all of that equipment, fans, which are the digital horses, they're the horses of the digital age. They don't belong in data centers, frankly. But fans are gone. And they run quietly. The data centers are silent. It's pretty amazing.
Right. So I believe in your materials it says that you reduce you impact the part of the server that gets hottest the first. So you hone in where the most heat is generated first. So does that mean you actually cool the chips in the machines?
Yes.
The servers?
Yes. We cool the chips first. Well, it doesn't have to be first, but we cool the chips with forced convection because that requires a special, what we call in the engineering field, it's forced convection. We push with a pump, we push it over the chip and with metered flow, pick up that heat, but we cool all the rest of the components with the same liquid. So whether it comes in first or last, depending upon what your objective is, you can cool the entire electronics with the same fluid, and it's very inexpensive to do that with very little power consumption. And one of the interesting things is you can migrate from an air-cooled data center to a liquid-cooled data center, one server at a time. You don't have to redo your whole data center. You don't have to make space for tanks or anything like that. You can simply take a server out of the rack that you currently have, if it's being what they call refreshed or replaced, and you can replace it with ours. And one of our servers is equal to 4 or 5 air-cooled servers. So you can actually reduce, as you go along, you can reduce your electric energy usage, and it doesn't cost you anything because you're spending money anyway. You would spend it on the air-cooled servers or on ours.
So does LiquidCool Solutions typically ship out its various components, and it's the responsibility of the data center, your client, to install everything? Or does LiquidCool do the installation and engineering necessary to accommodate your equipment as well?
So we have an ecosystem around us, which includes contract manufacturers to make the equipment and companies that install the racks and service the racks. And we also have even a company that we work with closely, which does construction management of data centers. So we could either sell a single server, or you can sell a installation, or you can sell the whole data center.
Okay.
It depends what the client needs.
Okay. And so if I wanted to buy specific products that LiquidCool Solution manufactures, what exactly would I get? I get a server? What else?
So you need to know that all of the components are off the shelf. And so you, as a client, would tell us what you want in the way of processors and what you want in the way of memory and storage. And we would buy the same components that Dell uses or HPE uses from the same suppliers. And our contract manufacturer would package them in our chassis, which is a standard chassis that goes into standard data center racks. And we can modify the rack that you already have in a couple hours to accommodate our technology, our servers, and then you're off and running. But what's amazing is how easy and inexpensive it is. There's a general conception that switching to liquid cooling, whether it's in row or back rear door or cold plate, is expensive. Actually, it's less expensive than just replacing your air servers with more air servers.
And as far as buying the different components from the different manufacturers, does the client usually have more bargaining power, more leverage in making those procurements, or does Liquid have more leverage?
So that's a good question. It may turn out, it depends on who the client is, of course, because we're talking about volume. But in general, the contract manufacturer we work with is large enough to get good pricing. But if you're a substantial one of the Big Seven or whatever, you might do better, and in which case you can license our technology.
Okay.
And make your own service using it. Yeah.
Okay. So do you do a lot of licensing?
Well, we don't do a lot because a lot of companies aren't quite there yet, but we've done it once with some mixed success. It's more complicated because we want to make sure that the quality is there. So we want to have some control over the manufacturing process to make sure the product is, we can be proud of what the product is.
Okay. And so I understand that your solutions reduce airborne humidity. Can you talk about that?
Well, there's no humidity issue at all. In fact, all the electronics are immersed, submerged in this dielectric liquid. What that means is that we can pretty much locate equipment anywhere. We don't need a data center. We don't need a white space. We don't need a clean room. It can go even outside. All we need is power and connectivity. And we can locate equipment any place. We can locate it on the roof of a tractor in a field. We can locate it in the hood of an autonomous vehicle, or it could be in a data center.
And can you talk about the dust profile too? Is there any dust at all?
No, dust is irrelevant. You can actually wash these things off you can wash them down with a hose. So if you're in an outdoors application, dust is irrelevant. We've tested a rack of servers for 5 years in the back dock in a community in Minnesota. And the equipment was exposed to outdoor temperatures that range from minus 10 degrees Fahrenheit up to about 100 Fahrenheit. And the systems were running at 100% load for 24 hours a day, 7 days a week for 5 years. And when you pulled the equipment out just to look at it to see how it was working, the fluid was tested brand new. Every quarter we would test the fluid, and the equipment, the electronics were still shiny as if it was a brand new board. So it's pretty amazing, actually, what this difference is. It's just, in my mind, the analogy is the difference between horses and cars. That transition in the early 1900s, late 1800s, 10 years and horses were gone because it was just such a better solution for everyone.
So are you typically brought in to address a limited footprint in the data centers that are experiencing the most trouble, that are heating up the most? So do you, is it more of a surgical implementation, or do you do implementation throughout the entire data centers in some cases?
Well, it's what's interesting is there's two things going on that are really a tectonic change. One of them is the fact that the server processors are getting too hot for air. The other is the movement toward the edge of the network. What's happening is, because of latency issues, the need for fast response driven by the latency requirements of, for example, autonomous vehicles, a lot of computing is done much closer to where you are than the nearest data center, which could be 150 miles away. Well, the reality is that those are two different problems to solve, but our technology, which is proprietary, does a better job than anybody else at solving both of them. So to your question, it's really what the customer is looking for. What problem do they have to solve? My general approach is to present what we can do and then ask, now that you know what we can do, what would you do with it? to solve your problem.
Okay. So, is there an application for LiquidCool Solutions at like 5G base stations? You talk about
Yes.
getting to the edge.
We have a boot box size device that can fit on a street lamp. And it could be it lasts forever, and it's you can install it. It requires no maintenance and doesn't require any air conditioning or water or any of that. And so you could literally have one of these on street lamps or light poles, or it's amazing. Once you get into the once you can cut the tether from all that infrastructure that you would otherwise need, suddenly new opportunities open up, such as installing on light poles.
And so for that, you would sell the equipment or sell a license and allow the
exactly
5G company to
right. The telco or whatever would build it, put it up.
So for the primary business at the data centers, is the demand, is the heat in the chips a function of gaming mostly, or AI, or just general computing that's has higher requirements for speed and so forth?
Typically, IT equipment hardware lasts 5 years, not so much because it wears out, but because it's technologically updated, needs updating. But what's the big change more recently is the fact that the AI has become a big factor. And the amount of energy, electric energy that data centers are going to consume in the future is mind-boggling. And so anything that can be done to reduce that is important. Now, what's interesting is that for a typical data center using air, almost over half the energy going into the data center is just to cool the other half. In our case, it's 2%. It literally reduces, in that kind of a data center, the demand for energy by 40%. Also, space is an issue. I mean, data centers take a lot of square footage. We reduce that space by up to 70%. It's just a completely different mindset. And once, I think our view is, frankly, once it gets out there and is with some widespread applications, I think the people are just not going to go back, because one of the interesting things is, in addition to all these environmental benefits, it's less expensive. We literally save millions of dollars. We did a study of a data center. It was a $45 million facility, which included about 20 million of IT equipment and 25 million of infrastructure. Between the savings, it was for a telecommunications company. Between the savings on CapEx, capital expense up front, and operating expense, the entire $45 million would have been repaid in 3 years. It's amazing how inexpensive this turns out to be compared to the alternatives, which are bad.
Are there any government incentive programs that LiquidCool is benefiting from due to your positive environmental profile?
Well, it takes a lot of time and effort and energy to apply for those programs. There are programs out there. We typically would prefer to partner with larger companies to take advantage of them. Let's be frank. I mean, LiquidCool's, although it's not a new company, is small. And when you're spending millions of dollars on IT equipment, you want to know that the company's going to be around 5 years later when you need to call somebody for service or replacement. And so we think working with partners in those to reach those customers is the best way to get there.
And just as far as contracting, do the data centers customers base their pricing? So the contract between the data center and the customer, is that at all a function of capital expenditure by the data center? So do the would it be a disincentive for a data center to use your technology, even though it's great, it has all these advantages, But if my customer is going to look at my capital expenditure and that's a function of how they pay me, may I be motivated to continue spending more than I need to recapture that via my contracts?
Well, so co-location facilities are data centers, which basically where customers bring in their own equipment, and the co-location facilities rents is being paid for space, power, and cooling. And so when you reduce space, power, and cooling for a customer, that obviously is a disincentive for them to want to welcome you in. However, because of the world is changing for everybody, and because of the AI and other hot chip applications, they can't get around it anymore. So what has